Hi, my name is David Abbott. This is Sean Antonelli, and today we're going to be making a physics car. This car is going to be rolling down a ramp and travel 1 meter with an egg in it, and it's going to hit a wall, and hopefully the egg does not crack. This will be the materials that we're using.
The car is going to be made out of sponge cake,
graham crackers,
hard shell chocolate,
fruit roll-ups,
marshmallows,
frosting,
and the wheels are going to be Oreos with skewery.
So let's go make it. Alright, so to start we're going to mix in some of our ingredients right here. Right here we have egg yolks, orange peel, our orange juice, vanilla, sugar, and flour. And what I'm doing right now is I'm mixing the flour into all those ingredients that I listed prior to the flour. And this is going to be part of our cake. And what we're going to do next is mix egg whites, cream of tartar, and sugar together, and it's going to get mixed into this mixture right here. Alright, so now we're going to add in egg whites and cream of tartar. So egg whites. There's our cream of tartar. We're going to mix this together until soft peaks form, and we're going to add some sugar in. Alright, so now I'm stirring in my egg white, cream of tartar, and sugar mixture into the dry ingredients plus the egg yolk and the orange juice. And the purpose of this is to make it light and airy cake when it bakes. Alright, so now we're pouring all of our ingredients into the baking pan. And it's going to go in the oven for about an hour on 310 degrees heat, and we'll go from there. Alright, so today we're going to be using a kinematic equation twice and a free body diagram to determine the final velocity of the car as it hits the wall, and these physics concepts are going to be used to determine if the final velocity will be great enough to cause the egg to A, fly out of the car, or B, crack when the car hits the wall. Alright, so the first kinematic equation is going to be final velocity squared equals initial velocity squared plus 2 times acceleration times distance. And this kinematic equation is going to be taken from the top of the ramp to the bottom of the ramp. So it'll be final velocity squared equals 0 squared, the initial velocity will be 0 meters per second, plus 2 times 9.8, 9.8 is the acceleration, times the ramp length. And what that is going to do is find the initial velocity of the car when it exits the ramp. And so that initial velocity is going to be used on the second equation. So, once again, we'll reiterate to you, that's what the equation is from the top of the ramp to the bottom of the ramp. Okay? And so, the second equation is going to be the same thing. It's going to be final velocity squared equals initial velocity squared plus 2 times acceleration times distance. So, and this is from the floor to the wall. So it's going to be final velocity squared equals the previous final velocity squared plus 2 times acceleration from an FED that I'm about to show you times 1 meter. So, here's that second equation. And that's what we're going to be using. And so, for the free body diagram, you're going to have your force of acceleration going in the direction of the right, a force of friction to the left, and then force of gravity down, and natural force up. And so, you'll find out your natural force, which is going to equal 9.8 times the kilograms of the car plus the egg. And then, to find your force of friction, what ends up happening is your force of acceleration is 0, that's being acted on the car. So it's going to be negative force of friction equals mass times acceleration. And so to find that, it's going to be negative mu, and that's the mu of the surface that the car is going to be traveling on. Negative mu times 9.8 times the kilograms of the car is going to equal the kilograms of the car times acceleration. And so you're going to solve all that out to equal the acceleration. And so you're going to be solving by the acceleration. So you would just solve this side of the equation out and divide it by kilograms over here. That would equal your acceleration. And it would be a negative acceleration as well. And so this acceleration would be plugged back in to this equation right here. And that would give you your final velocity squared. So just square root that. And that'd be the final velocity of the car as it hits the wall. And that would, determining how big that is, would determine if the egg would hit the wall and the car would hit the wall and cause the egg to crack or fall out. And we're going for the final velocity to be small enough so that that does not happen. And that's our physics concept.
Okay, I'm going to be explaining the pictures to you guys. Right here, we have the diagram of the wheels. These are two Oreos. The cream is not in between them, and then the brown is the wooden skewer. And it's 8 centimeters between the Oreos and the skewer, and we have the actual thing for you right here. Alright, so this is the front view of what our final product is going to look like. This represents the sponge cake, and then the egg sticking out, and then the black circles here, the Oreos and the wheels and the brown skewer. And then these are marshmallows, and the two lines are graham crackers. The bottom layer of the graham cracker is to help the wheels stay in place so the skewer doesn't create a bigger hole in the wheels. And the top layer is to hold the egg up. And we couldn't really draw this on here, but the sponge cake will be layered with a hard shell chocolate and topped with a layer of icing. And this is the side view of the car. We hollowed out the sponge cake to put the egg in, and the red line represents fruit roll-up, and pretty much we already covered all these in the top layer. So, yep.